In this video we'll be building this electric bike. I got the bike cheap from a classified ad with the intention of somehow sticking a motor on it. After measuring the parts that were important, I started trying to figure out how best to mount a motor. A fella called vtsteam on the MadModder forums, who's been nothing but a great help throughout this project, suggested driving the rear wheel directly via friction. A fair few bikes seem built by driving the tread of a tyre with rollers, but I decided that'd be better and probably more novel to try and just drive the rim instead. vtsteam again suggested an idle roller on the opposite side to give the pinching action. It's a bit of an elaborate design, but it didn't seem too bad since I was already planning on building a rear carry rack for the batteries. The motor I'm using is a brushless outrunner style motor, rated at 65 amps. It's fairly powerful for its size. With it I'm using a cheap 100 watt speed controller I bought from China via eBay. To control the speed controller I'm using a cheap servo tester. These arms will hold the contact rollers against the wheel, as well as hold the motor and a set of gears to reduce the RPM. The sides are cut from 2mm steel. I used printed paper templates to locate the holes in the plates, as well as to give the outline a cut. Since cutting oil tends to dissolve with spray glue, I spray painted over the template to give a more permanent outline. These are then stuck together into a stack with carpet tape. I bought a new old jigsaw at the car boot sale. It's better than the old one, but it has a habit of ejecting the blades due to its clever toolless design. I stuck a new template on since the oil also stripped the paint. I never intended to use this sander with metal, but it worked okay. I then used the belt sander to get the convex surfaces. And then the plates were separated. I marked out these aluminium plates in a more traditional manner. I first tried drilling the holes for the bearings with forcing the bits, which I'd also turned down slightly in an attempt to make a well-fitting hole. It's kind of interesting that you can drill aluminium with forcing the bits, although it's slow going and they do tend to grab. The holes came out way undersized though, and I ruined the bearing trying to push it in. So I moved the plates to the 4-jaw chuck and just bored the holes. This worked out a lot better. I'm using some rotary burrs I found in a car boot cell to rough out the curved front. And then sand them to the line. It was slow going since the plates got hot. The motor needed a new shaft to accommodate the gear and reach the support bearing. I started by facing and centre drilling both ends of a bar, then setting up for the next shot. The camera fell over. I've been tempting fate trying to film the lathe like this. The tripods were purposed from a telescope tripod, and luckily the giant telescope mount took most of the impact. Well, the handheld recording wasn't working out, so I built a cheap knockoff of John Mill's camera rail. This lets me get some nice camera angles as I turn it to a 10mm diameter between centres. The lump at the end of the chuck transmits the torque to the workpiece since it's only supported on a centre. Turning between centres like this lets you take the workpiece on and off the lathe without losing the position. An 8mm shoulder was then turned to accommodate the gear and the bearing. And then cut a groove for the circlip. These motors have some strong magnets in them. I trapped my fingernail every time I reassembled it. Shafts were also turned for the idle wheel and the larger gear. For the keyway I used the shanks of drill bits to figure out what size key I'd need. For cutting the blind keyway I first drilled an entry and exit hole. Then used the parting tool sideways in the lathe, which acts like a rubber shaper when you move the carriage. When cutting the 4mm keyway I found it worked better if you angle the tool away a fair amount to stop it from wanting to dig in. The standoffs were cut and threaded on the lathe. Then with the arms part assembled I could locate the screw holes in the bottom aluminium plate. I use the shafts and spacers to align the top and bottom plate when locating the holes, and then locate the motor mounting holes. Various circlip grooves, spacers and another keyway are also cut to finish the shafts off. The struts of the carry rack were made from 30 by 30 by 3 angle iron. A bit overkill, but it's what I had on hand. Drilled holes was filed into a slot to give the thing a bit of adjustment in its mounting. Here's how you put a handle on the file. After drilling a hole in the handle that's a bit undersized, you heat up the tang of the file with a torch and then let it burn itself into a good fit. Then shove it in after it's cooled. The big file really removes metal fast. Long spacers were made from 16mm bar. These fit either end of the 30mm box section. The rectangular aluminium bar was faced square enough in the forge or chuck. Holes were marked out and drilled. The 10mm drill drilled fairly undersized, so I used one of those burrs to ream the hole bigger. Some more bars were then made to attach the forward end of the bike. It took some time to machine these first rollers. There's a lot of aluminium to remove and it took a while to find a tool geometry that could break the chips. Both the carry rack and the arms aren't fully completed. The rack needed its upper half and the gearbox needed a cover, but it should be complete enough for testing. I'm no electrical engineer. This is the wiring diagram to the bike, and to help me keep track of the wire colours. First I replaced the battery connectors with some EC3 connectors. The original ones are unisexual, and I had visions of plugging one battery into another by mistake. Neither of my soldering irons get hot enough to compete with a thick copper cable and large brass terminal, so I'm cheating by using a flame. I made a wooden box to house the meter and servo tester in. The front panel was made from all of that 2mm steel, using a template to locate the holes. Soldering these little DIN connectors is really fiddly. It's not very discreet or waterproof. I'll be replacing it at some point. The first test was a disaster. There wasn't anything left to film. I really underestimated the amount of spring tension that would be required, and the very soft rubber I used for the rollers tore too easily. First I started replacing the rollers. I machined down and threaded the drive spindle, and turned down some hard rubber skateboard wheels for the roller itself. I also doubled up the springs on the arms to get a lot of tension. For the other roller I turned the left hand thread on the lathe. The idea being that the nut will tend to tighten itself as it turns, although I ended up mixing the two threads up and just Loctite the nuts on. And the second test was way more successful. With the massive spring tension, the thin bearings ruined after just a short while. Ordered the biggest bearings I could fit into the space available, which are rated for about double the load of the original ones. These were Loctited in place. For holding all the electronics and batteries I made a wooden box. Then after painting the box and putting the electronics inside, it was time for the final assembly. The big wooden contraption front of the seat is for the camera. Also made a quick throttle lever using a potentiometer from an old RC transmitter. The batteries are charged with one of those cheap 4-button LiPo chargers, powered by no PC power supply. And that's the bike working. Apologies for the wind noise and the wobbly footage, but I still can't figure out how to prevent that. It didn't last long though. After about 15 minutes it started to rain. Rather than head home, I decided to press on further to North Station and wait for the rain to stop. I thought the rain wouldn't last too long or get too heavy, but I was wrong. It turned into a full-blown thunderstorm. It was about at this point that my sister phoned me saying she'd been locked out, so I had to head back. I was also concerned about the puddles getting too deep and the track getting too muddy if I waited any longer. So I taped up the electronics to try and keep the water out and set it off. But, like an idiot, I forgot to tape up the most important thing, the speed controller. It took about 5 minutes for water to find its way inside and short it out. I ended up having to push the bike home the rest of the way. Well, the only visible damage to the speed controller is this lead on the capacitor. I'll probably buy a pair of replacements and see how it goes, but the whole speed controller isn't too expensive to replace. Everything else seems to be holding up fine though, including the heavier bearings. The only fault was getting the thing wet. And so, in conclusion, I suppose I'd say that this isn't the best design for an electric bike going, but it does work, surprisingly. I should probably waterproof it before next time I take it out. Oh yeah, one last thing. I decided for the novelty I'd keep track of how much I spend on this, since the first question I imagine people would ask is how much does the thing cost? So, every single thing I bought, I kept track of. And so here's the total price. With commercial bikes costing £500 at the low end, I think I'd say this is a pretty successful build in terms of price, but it's still a hell of a lot of money. What's interesting is that the motor, speed controller, batteries, all them things didn't cost too much. I mean, I suppose you keep that under 200 quid if you're careful, but what did cost money was spending small amounts of money here and there, you know, 5 quid here, 10 quid there. All that stuff adds up quite quickly. That's what ended up making the price so high. But yeah, thanks for watching.